My name is Alfredo Terrazas, and today's date is May 2, 2021. This is my submission for CIRC09 Attempt A. In this attempt, we use a servo to represent the light level that the photoresistor is receiving, or rather to display it. And in addition, I added 4 LEDs to also represent a sort of a power level to also display how much light the photoresistor is receiving. At the top, we went ahead and set up the My Servo to attach the servo to the code. We set up the integer photoresistor to analog pin 0, same pin. We set up the integer light level, which is going to be used to read the light level that the photoresistor leaves. And then the 4 LEDs, they're individually assigned to pins 3, 4, 5, and 6. In the void setup, we went ahead and attached the servo to analog pin 9, and we set all 4 LEDs as outputs. In the void loop, we start by setting up thresholds. These thresholds are going to be used to light up or light down the LEDs based on how much light the photoresistor is receiving, or rather the value that is being stored by the photoresistor. We use, like we said, the light level to store the analog read command from the photoresistor. This variable we use to store the value that is being read from the photoresistor. Then we use the map command on the same light level to go ahead and map the values for the photoresistor to match that of the servo, so that the servo can spin from 0 to 180. And then of course we go ahead and use the write command to write whatever the light level is onto the servo, so it will spin according to the light level that the photoresistor is receiving. And then we set a delay of 15 milliseconds. Then we set up an array of if-else statements, which will help the LEDs light up in order. And it simply sets up so that if the photoresistor is greater than the threshold that we set up on top, it will light up the LEDs in order. And at the bottom, it's the opposite, so that if the LEDs that are set up on top are not lit, then they will be set to low, so that they can power down as the light decreases or increases by the photoresistor. So to show this in action on the Arduino, we have a lot of wires. We have the servo itself connected to its data pin on digital pin number 9, and it's got its jumper cables for 5V and ground. Of course, the jumper cables for 5V and ground to the Arduino are, as always, right there, 5V and ground. Aside from the jumper cables for the servo, we still have jumper cables for the photoresistor, with the 5V connecting to a 10K ohm resistor to the photoresistor, and then the ground connecting to the other pin via the jumper cable. The photoresistor still has a yellow data cable connected to analog pin 0. And we have the 4 LEDs ranging from green all the way to red being the max, red being the maximum, or rather the highest value the photoresistor can read. Each have their own 560K ohm resistor. Each has its own data wire connecting each pin on the longer lead to digital pins 3, 4, 5, and 6. That's the entirety of the Arduino. Now to show it in action, it's going to be a little hard, so I'm going to do it from this angle right here so I can show both the servo and the LEDs. As the photoresistor loses light, we have the servo moving, and we have the LEDs lighting up in accordance. So the more light it receives, the less LEDs that are on, and the servo moves to its default position of 0, and then it moves up to 180 as the photoresistor stops receiving light, up to a maximum of 900 for the photoresistor, which again we mapped for 180 for the servo. Again, my name is Alfredo Terrazas, and this is my submission for CIRC09 Attempt A.